right, so today, please make sure you download the Word document and open it up so that you can see it correctly. But today you're learning about inverses of a square root function as an inverse. The good news is that you've already had a lesson on inverses, so this should be much faster. Remember that an inverse is basically when you switch the x and your y variable, like your independent variable is exchanged with your dependent variable. So that's what the inverse is. So let's try it together. Example number 1. And you probably will need graph paper, so either, I don't know, print the document or just get some graph paper. Example 1. I want you to graph this parabola. F of x equals x squared. That is a parabola with the vertex at 0, 0. So vertex 0, 0. The a value is 1. So, in case you forgot how to graph parabolas, we use a counting pattern. A times 1, A times 3, and A times 5. So let's apply it here from the vertex to the right one, and then 1 times 1. So that's just 1. From the vertex to, not from the vertex, from the point that I just put. Now I'm going to do A times 3. So to the right one, up 1 times 3. And then I don't think I can fit the other dot. So then it looks like this. The other side is symmetrical. If you're going faster or slower than me, that's okay. The answer key is it's in Schoology. It's a PDF document. You can look at the answer key and go at your own pace. So now that, oh wait, what happened? Oh, I forgot to put this dot. No, what? Okay, that's not right. It's supposed to be right here. Okay, it's still okay. So now you make a table of values for that. Got the answer key. And the table of values should be -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. This dot was wrong. That's your table of values. And just like all parabolas, the domain of the parabola is always all real numbers because x can be any number. And then the y values, so the range, the y values are restricted. It's only 0 to infinity. So you could just put y is greater than or equal to 0, or you could put 0 to infinity if you want. So that's how you graph a parabola. Reminder. Okay, now I need you guys to find me the inverse. So just like we did earlier this year, to find the inverse, you're just going to switch all these x values with these y values and flip them around. So let me make the table first. The -2, -1, 0, 1, and 2 are going to become the y values now. So -2, -1, 0, 1, 2. And then the y values are going to become the x values now. It looks like that. And now you just try graphing that, and that's how you graph an inverse. So 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So the inverse is going to be a sideways, a horizontal parabola. So your inverse of the vertical parabola is a horizontal parabola. Now try to do the x values of this inverse. So the x values look like now they're restricted. They go from 0 to positive infinity. So I'm just going to write x is greater than or equal to 0. And the y values, since there's arrows going up and down forever, that means it's all real numbers, which matches our original. Remember, for the inverse, the domain and the range would just flip around, but the y would become an x. So I guess pause for questions. Keep practicing. The graph of the inverse is the reflection of a line y equals x. And then just like before, is the inverse of a quadratic function considered a function? Your answer should be no, because a sideways parabola fails that vertical line test, so it's not a function. Just like the absolute values graph, so same lesson, just different function. Okay, now you try it again on example 2. Example 2. Given this g of x function, I want you to graph it, and then I want you to graph the inverse. Plus find the inverse algebraically. Let's do the graphing part first. So literally the same thing I did with example 1. Here we go. Here the vertex is 4, -1. And the a value is -1. So let's graph that. 4, -1. And since the a value is -1, I'm going to do to the right one, down 1. And to the right one, down 3. So look at this. Okay. And make sure you have graph paper or a printer, because you will need graph paper for your progressive test. So now that's the parabola. I just fill in the table. 2, -5, 3, -2, 4, -1, 5, -2, 6, -5. Looks right. The domain is always all real numbers for parabola, or for vertical parabolas. The domain is always all real numbers. Here the range is restricted to -infinity to -1. And you can write it like that if you want to, -infinity to -1. Or you can just put y is less than or equal to -1. Either one's correct. Now you need to do the inverse. So again, to switch the x and the y values. 2, 3, 4, 5, 6. -5, -2, -1, -2, -5. And graph those. -5, 2. -2, 3. -1, 4. -2. Alright, so the inverse of this parabola is opening to the left, because the original function opened down, so the inverse is opening to the left. And the domain is restricted to -infinity to -1. You could also just say x is less than or equal to -1, and the range is all real numbers. So exactly what I did on example 1. Obviously, you do need to know how to do the inverse for the progressive test, except for I think it's multiple choice, so you have to select the right one, the one that matches. So now, now you need to do the inverse algebraically. Again, it's going to be multiple choice on your progressive test, but you have to know how to do it. So here's how you do the inverse algebraically. I've shown you before with absolute values, but what we're going to do is you take the function, like the g of x function here, and you're going to replace the x with the y, and then the y with the x. So in other words, instead of putting g of x equals, which means y equals, you're going to now put x equals negative parentheses y minus 4 squared minus 1. So now go ahead and solve for y. So again, to find the inverse algebraically, you will have to switch the x and the y variables and write x equals negative parentheses y minus 4 squared minus 1. And now to solve for y, we're going to isolate the y minus 4 squared. So I'm going to do plus 1 on both sides. X plus 1 equals negative parentheses y minus 4 squared. Then I'm going to get rid of the negative by multiplying the entire thing by -1. So negative x minus 1 equals y minus 4 squared. And then you can get rid of the square by taking the square root. There we go. And this is going to be the square root of negative x minus 1, which is okay. As long as you pick the right numbers for x, this will work. Square root of negative x minus 1 equals, Okay, then you have to remember the even, odd rule. That's coming back on your progressive test. When you take the square root of a squared power here, this is supposed to be the absolute value of y minus 4. So I'm writing it down, absolute value of y minus 4. Some of y'all like to skip that step, and that's okay, but then you still have to show me the two answers, which means to get rid of this absolute value, you're supposed to break it into like two cases, the positive case and the negative case. So here's what I mean by the positive case. The positive case is just going to be exactly what you see without the absolute value. So square root of negative x minus 1 equals y minus 4. That's the positive case. Don't forget to solve for y still. And then for the negative case, I would just put a negative square root of negative x minus 1 equals y minus 4. So I can slow down here. So again, I'm getting rid of the absolute value by breaking it into the positive square root and then the negative square root. So your final answer should be a pair of equations. So that means two equations. So your final answer should be y equals the positive square root of negative x minus 1 plus 4. You can put the 4 first if you want to. And then the other answer should be y equals the negative square root of negative x minus 1 plus 4. So technically that's your pair of equations. And if you look at my answer key online, oh, it doesn't have it. But technically, because these are almost the same equation, it's just one is a positive square root and one is a negative square root, I could write it with a plus or minus. Did Elaine tell you? Now they're making fun of me.
You also have to write domain and range, like domain, just the domain.
Huh?
Oh, you have to write a domain, right?
No, I don't think so. We just have to find the inverse, so there it is. Oh, we don't have to do the domain because square root functions already have restricted domain, so we just leave them like that.
Oh, okay.
So, like I was saying, is you can leave your answer like that because that is a pair of equations, or because they're almost the same, you could also write it like this: y equals plus minus square root of negative x minus 1 plus 4. That's also correct. And it's multiple choice, so just select the one that matches. So, questions on how to find the inverse algebraically. Pause for questions. All right, so now you should try example 3. Example 3. Given this function g of x, negative x squared plus 8x minus 17, restrict the domain of g of x so that its inverse is a function, and then find the inverse function. So again, with same thing we dealt with last term with absolute values. Remember that if you graph an entire parabola, the inverse will not be a function. So now we're going to have to do some domain restrictions. But first, let's just start with find the inverse of this function. So if you're going to find the inverse of this function, I first recommend to change it to vertex form. So step 1. Step 1. Change to vertex form. Vertex form. So in other words, I need to take this negative x squared plus 8x minus 17, and I need you to change it to vertex form. The way I would change it to vertex form is by completing the square. So from last unit, I'm going to do y equals. To complete the square, the coefficient of x squared needs to be a positive 1. So we cannot complete the square like that. We're going to have to take out a negative here. So negative, parentheses, x squared minus 8x. Leave a little bit of room to complete the square. Minus 17. You can complete the square however you want to, but this is what I do. I take the negative out of the negative x squared and the positive 8x. I leave the minus 17 alone because that has nothing that can be left alone. And now I complete the square. 8 divided by 2 is 4. 4 squared is 16. So plus 16. When you complete the square, you have to undo what you just did. So it looks like I added 16, but I didn't because there was a negative in front of my parentheses. So technically, I actually did a minus 16. So then to undo a minus 16, I have to add 16. Okay, so final answer for vertex form, I hope you got y equals negative parentheses, x minus 4 squared minus 1. So here, step 1. So we're doing example 3 right now in today's Schoology folder. Example 3, step 1, change it to vertex form. Questions on how to get to the vertex form. Let's pause for questions. Okay, so now that I have it in vertex form, I need to do what it says. Restrict the domain so that its inverse is a function. And the good news is that if you notice, example 3 is the same thing as example 2. I did that on purpose to save us time. So basically, here's what's happening. Negative x minus 4 squared minus 1, I've already graphed it for you. It's called example 2. So like I said, we cannot graph the entire function, because if you graph an entire parabola, the inverse is a sideways parabola, which is not a function. So now we're going to take like an eraser or a whiteout, I guess, and we only want to graph half of this parabola, which means I always recommend graphing to the right of the vertex. So I'm going to literally erase half the parabola on example 2. So there we go. I only want to graph to the right of the vertex. If you want to be different, then graph to the left of the vertex, and that'll be okay. However, on the progressive test, you're going to have to graph to the right of the vertex, because that's what the directions say. So since I'm only graphing to the right of the vertex, here's my domain restriction. So domain restriction for g of x, because this was called g of x. And that would be x is greater than or equal to 4. So that would be one of your answers. You type it without any spaces, or it's going to mark it wrong. So again, the way I got x was greater than or equal to 4 is from this parabola, I only graphed to the right of the vertex. So the vertex is at 4, negative 1, and I only graphed to the right. Okay, now here's what happens if you do restrict the domain. Then that means that your inverse, instead of graphing like the positive case and the negative case, because you went to the right of the vertex, then we're only going to be graphing the positive case. So like this one here, the positive case only. So on your graph, you're only graphing half of the parabola, or yeah, half of the inverse. And it would be the top half. The top half matches the right half here. So final answer, it says find the inverse function. So my inverse function, so the little g negative 1, the inverse function should just be the positive case that we already found on example 2. So I'm just going to write the positive one, which means positive square root of negative x minus 1 plus 4. And definitely on the progressive test, you have to do the domain restriction, and you have to find the correct inverse function. So all right, so now continuing the examples for today, we need to use this composition of functions to see if the things are inverses. We've done it before. Here it goes again. If f and g are inverses of each other, then when you use f of g of x, that's going to equal to x. And when you do g of f of x, that also has to equal to x. If it does, then yes, they're inverses. If it doesn't, then there's no. So we're going to show a lot of work, but on your progressive test, this is just like a yes or no question, so just answer it yes or no. But here it goes. Example 4, I need you to tell me if f and g are inverses of each other. Here's how you prove it, or how you check, I guess. First, we're going to do f of g of x. Okay, this f of g of x means I need you to take the entire g function, so take this whole g function and plug it in for x in the f function. So do it now. Take the entire g function and plug it in for x. in the f function. So that means my f function will be 2 parentheses. Instead of putting x minus 1 squared plus 3, we're going to replace this x with the entire g function. So replace the x with negative square root x minus 3 over 2 plus 1. Okay, now simplify this mess and see if it equals to x. So the way I would simplify is the positive 1 and the minus 1 will cancel each other out, so you're left with a negative square root of x minus 3 over 2, quantity squared, plus 3. Since the plus 1 and the minus 1 cancel each other out. Now, since you're squaring the square root here, it will cancel out. And the negative also cancels out because when you square a negative value, it becomes positive. So basically, the negative will go away, the square root will go away, and the square will go away. They're all canceling each other. Let me let Amy in. All right. So then this will become 2 times x minus 3 over 2 plus 3. So again, the square root, the negative, and the square cancel each other out. Let me mark Amy C here. Okay, now keep simplifying and see if it does equal to x. Amy C here. All right. So then this is going to become x minus 3 plus 3 because the 2 will cancel with the divided by 2, and obviously the minus 3 and the 3 cancel each other out. So check. F of g of x does equal to x. So far that looks good. It looks like it will be a yes. They are inverses. However, you still have to check the other one because sometimes they don't match. And by the other one, I mean, now we need to do the g of f of x. G of f of x. I know, lots of work. So to do the other one, we're just going to repeat. And this time I need you to take the entire f function. So where is it? Like this whole f function. And plug it into x in the g function. So again, take the entire f function and plug it in for x in the g function. And Amy, if you just got here, we're doing the notes in today's Schoology folder, and then I'm making a recording so you can just watch the beginning. So now we're on example 4. So I'm going to write g of x equals negative square root of x minus 3 over 2 plus 1, but instead of putting x, you need to replace it with the f function. 2 x minus 1 squared plus 3. There you go. And okay, now you simplify that. That's going to be negative square root of, okay, let's just try to save some writing and do it in our heads, but the positive 3 and the minus 3 will cancel each other out. Plus 3 minus 3. The 2 and then divided by 2 will also cancel each other out. So all that's left in this square root will be the x minus 1 squared. And then the plus 1 at the end, don't forget that one. Okay, now here comes the confusing part. Well, okay, not here, the next step. But right now you have a negative square root of x minus 1 squared. The square will cancel with the square root. You just have to do the square root of x minus 1 squared is absolute value of x minus 1. Now, don't forget the negative that's already there and the plus 1 that's already there. So remember the even odd rule still applies. So when you take the square root of a square power and it comes out to be x minus 1 to the first, you have to put absolute values. Okay. Now let's break this into 2 cases, and I'll tell you which case to pick. We're going to do the positive case and the negative case just for practice. The positive case is just you write exactly what you see without the absolute values. So let's just write negative. Let me put parentheses x minus 1 plus 1. So that's called a positive case. I just got rid of the absolute values and nothing else. I didn't change anything else. Now let's do the negative case. So for the negative case, first of all, there's already a negative there. But for the negative case, you need to do negative x minus 1. So the difference between these two is the negative case has this extra negative sign here. So notice, the positive case just has the regular negative sign that was already in the question. The negative case has two negative signs in there. The original one that was already in the question, and then the extra one you have to put for the negative case. Okay, now, you're not going to actually simplify both. You only simplify one case, and here's how you tell which one to simplify. From the very beginning, f of x has a domain restriction. Here it is. It's to the left of the vertex. Left of vertex. So remember I told you, like on the previous example, when you do to the right of the vertex, we would have gone with the positive case. But when you do to the left of the vertex, you're going to have to go with the negative case. So we're not going to do this one, we're going to do this one. So now simplify this thing and see if it equals x. Well, these negatives are going to cancel each other out. And you're going to be left with x minus 1 plus 1. Check. It does equal x. I know that's confusing, so I'm going to stop for questions and I'm going to let you do example 5. Pause for questions. So hopefully you were trying example 5 to see if yes, these functions are inverses or no, they're not. Okay, my hand hurts from writing, so I'm just going to show you the answer key. When I did f of g of x and showed a bunch of work, I did get f of g of x equals x. And then when I did the other one, the g of f of x, here's my work. And again, you can look at the answer key on your pace. But for that one, I guess the only confusing part is when it gets to getting rid of the absolute value here. When you get rid of the absolute value on that one, notice how like I only broke it into the positive case. Like I only did x plus 2 minus 2. I didn't even write down the negative case because, like I said, we were only graphing to the right of the vertex. So when you graph to the right of the vertex, you're supposed to only do the positive case. So I only did the positive case. And finally, for the last 5 minutes, I'll answer questions, but I want you to do the exit ticket for you to practice.